An AI coding agent you're using right now might have just stolen your AWS keys. Tenet Security disclosed Agentjacking, a new cyber attack that tricks AI coding agents like Claude Code, Cursor, and Codex into running malicious commands on your machine. Here's how it works. An attacker plants a fake error report in their website's source code, disguises it to look exactly like a real bug from Sentry, a popular error tracking service, then waits. When you ask your AI agent to fix open issues, it finds that planted fake error, treats it as a trusted instruction, and executes the attacker's code. Sounds impossible? Researchers achieved an 85% success rate. We're talking about 2,388 organizations exposed, including Fortune 100 companies, with successful hijacks across over 100 real enterprises. This isn't theoretical, it's happening in the wild. It changes everything about trusting AI agents with development work. And here's what makes it terrifying. The attacker doesn't need sophistication. They just need your public API keys, which are often sitting right there in your website's source code, completely visible. Your AI agent sees those keys and assumes the attacker's instructions are legitimate. But wait, there's something even worse about how this actually plays out. To understand agentjacking, you first need to understand why developers love error tracking services like Sentry. When something breaks in production, and something always breaks, developers need to know about it instantly. Sentry catches those errors, logs them with context, and sends alerts. Developers then share those error links with AI agents. Hey Claude, check out this Sentry link and help me fix it. This workflow makes total sense. Sentry is trusted infrastructure. It's used by millions of companies. So when an AI agent sees a Sentry error report, it treats it as credible information, almost like reading official documentation. But here's where the logic breaks down. The AI agent doesn't verify where that error report actually came from. It just sees the format, recognizes Sentry's structure, and assumes it's authentic. An attacker can exploit this psychological trust by planting a fake error report that looks exactly like it came from Sentry, with all the right formatting, the right error context, the right stack trace. The AI agent never questions it. From the AI's perspective, it's just following instructions to fix a bug. The real genius of the attack is that it hijacks this existing trust relationship between developers and their tools. Developers invited their AI agent into this trusted workflow. And now that invitation is being weaponized against them. Let's walk through exactly what's happening. An attacker finds a website with a public API key exposed in the source code, and there are thousands of these. Then they create a fake Sentry error report. This isn't some crude knockoff. It includes everything a real error would have. A stack trace showing where the error occurred, line numbers, variable states, the full context of the crash. The attacker might even include helpful debug information that makes the fake error look more legitimate than a real one. They host this on their own website, then wait for developers to use AI agents on that site. When a developer asks their AI agent to help debug issues, the agent crawls the website's code, finds this beautifully crafted fake error, and sees it's formatted exactly like Sentry errors they've seen before. The AI thinks, oh, this developer has an open bug, I should help fix it. The error says to run this command to patch the database. And boom, it runs the attacker's command. What makes this so dangerous is the AI isn't being tricked in the way we usually think of hacking. It's not being deceived by a confusing prompt or weird formatting. It's being tricked by structure and context, the exact things AI systems are supposed to trust. The numbers tell the story. Tenet Security researchers found an 85% success rate when they tested this in the wild. Out of their test cases, about 15% failed, and that was mostly due to implementation details, not fundamental flaws in the attack. They documented successful hijacks at over 100 real companies. Over 100. Not hypothetical test cases, actual enterprises that got compromised. Scope of exposure is staggering. 2,388 organizations have vulnerable patterns in their code right now. That includes at least one Fortune 100 enterprise. Think about what a Fortune 100 company's codebase is worth. We are talking about proprietary algorithms, confidential business logic, trade secrets. One successful agentjacking attack could expose years of development work. And the attacker gets everything. AWS. Keys that unlock cloud infrastructure, GitHub tokens that grant access to private repositories, database credentials, API secrets, private repository URLs that map out the entire architecture. All stolen in a single moment when a developer asks for help debugging. The researchers published their findings, and what happened next is almost as troubling as the attack itself. Sentry acknowledged the issue, but essentially said it's not their responsibility to fix it at the protocol level. They called it technically not defensible from their end, which is corporate speak for not our problem. Agentjacking is different from older prompt injection attacks you might have heard about. Traditional prompt injection is where someone tries to trick an AI by embedding hidden instructions in text, like putting a fake command in user input hoping the AI will follow it. But agentjacking doesn't rely on hiding anything. It uses the structure of trust itself. The AI agent isn't being confused. It's being given what looks like a legitimate, structured request from a trusted service. This is more like social engineering than hacking. Compare it to a phishing email that looks identical to a real company email. The user isn't being tricked because the message is confusing. They're being tricked because it's too authentic. Agentjacking does the same thing at the code level. It's also different from supply chain attacks, where attackers compromise a legitimate library or service. Here, the attacker doesn't need to compromise anything. They just need to plant false data in a place where an AI agent will find it and trust it. The attack surface is massive because any website that an AI agent might crawl could be weaponized. It's not just NPM packages or GitHub repos. It's any public code, any documentation, any error report that exists online. And here's the thing that makes it scarier than traditional attacks. Most security teams aren't even looking for it yet. What are the real stakes here? Start with AWS keys. If an attacker steals your AWS keys, they don't just get access to your current infrastructure. They get access to everything your organization has ever built on AWS. Every database, every storage bucket, every compute instance. They could spin up expensive instances and rack up a massive bill, or they could steal data. GitHub tokens are even worse in some ways because they grant access to your entire repository history. A stolen GitHub token means an attacker can see every commit you've ever made, every branch, every pull request comment, every secret that was accidentally committed at some point. Private repository URLs reveal your organization's entire codebase structure, which services exist, how they are named, the architecture. And this is happening silently. No permissions dialog, no warning, no audit trail that says your AI agent just executed a command. It just happens while a developer is asking for help. The broader implication is that AI agents, for all their usefulness, create a new trust layer that hasn't been properly secured. Developers trust their AI agent like they trust a senior engineer on their team. But that AI agent is now an attack surface you can't easily monitor or control. It goes to places a human wouldn't go. It automatically crawls public code. It finds things that don't look suspicious because they are just data. And it acts on that data without hesitation. So how do you actually protect yourself? First, treat public API keys like what they are: public. Don't assume public keys are safe to leave visible. Even though they are technically public, they're often paired with private keys or used to identify your infrastructure. Rotate them regularly. Second, use environment variables and secrets management for everything. Never hardcode credentials directly in your source code, even keys you think are public. Use something like AWS Secrets Manager or GitHub's Secret Storage. Your AI agent won't crawl your deployment configuration. Third, implement strict permissions. Your AWS keys shouldn't have unlimited access to everything. Use IAM roles that grant minimal permissions. Your front-end code only needs access to specific resources, nothing more. Fourth, monitor AI agent activity. Some frameworks let you log what commands your AI agent is executing. Turn those logs on. If you see your AI agent executing commands you didn't explicitly ask for, that's a red flag. Fifth, be intentional about which AI agents you use with which code. Don't give your coding AI agent access to repositories with highly sensitive logic. And sixth, when something does look suspicious, don't assume your AI agent is hallucinating or confused. Treat it like a real security incident, Because it might be. Agent jacking reveals something uncomfortable about how we're integrating AI into our workflows. We're building trust faster than we are building security. AI agents are genuinely useful. They make developers faster, they catch bugs, they help solve hard problems. But they've also become new entry points for attack, and most organizations haven't even realized it yet. Here's what you should do. First, talk to your security team about agent jacking. Most of them won't have heard of it yet. Second, audit your public code for exposed credentials right now, not tomorrow, today. Use free tools like Git Guardian or just search your repositories manually. Third, assume any website your AI agent touches could be malicious. Just like you wouldn't run random scripts from the internet, you shouldn't trust that every website your AI agent crawls is authentic. The beautiful thing about human engineers is that they are naturally skeptical. They read documentation carefully, they question things that seem off, they ask why before they act. AI agents move too fast for that skepticism to kick in. They see structure and assume intent. As AI becomes more integrated into development, this gap between AI speed and human caution becomes a real security liability. The good news is most of these protections are basic security hygiene that you should be doing anyway. Agent jacking just makes the consequences impossible to ignore. Follow for daily AI news.